Hey guys, Mr. Elting here. I'm going to show you in this video how do you take the square root of an exponent, right? Well, it all stems from this basic problem, a problem that's not too unbearable. Get it? Unbearable. So the problem is this. What is x cubed times x to the fifth? Okay, and I made this up with random numbers on purpose because you have to remember that when we multiply exponents, we actually add the exponents. When we multiply variables, excuse me, with the same bases, we add the exponents. So, in layman's terms, x times x times x, that's x cubed, multiplied by x times x times x times x times x, which is x to the fifth. No wonder we say x to the fifth. Is simply just the sum of all of these x's, or the sum of the exponents, or x to the eighth, okay? Which is just all of these, right? Well, when we take the square root, what we're essentially asking is, what times itself will give me this? Well, if you think about it, 8 might not have a perfect square, but x to the 8th does, because if you think about it, x to the 4th times x to the 4th is actually, well, 4 plus 4 is 8. So when you take the square root of x to the 8th, you actually get x to the 4th. I know it doesn't seem like it makes a lot of sense, but really, when we take any exponent and we take the square root of it, what we're really doing is saying, hey, divide this exponent in half. All right? And so what's 4 divided by 2? Well, it's actually just 2. And that's the answer to this one. Now, some of you might be wondering, well, what the heck happens when you have, not something like this, but an exponent with a odd power, x to the 7th, for example? Well, I'm not going to be able to find two numbers that add evenly to 7 because it's an odd number, but what I always want to do is just subtract 1. Okay, and what's 7 minus 1? 6, of course. The reason why I'm going to do this is because I will be able to take the square root of this guy, and I'm always going to leave off that extra x to the first that I have left over. What's the square root of x to the 6th? Remember what we do? Divide the 6 by 2, you get x cubed. And then since I cannot take the square root of x to the first, I just leave it in the parentheses, or leave it under the square root, excuse me, and I don't bother putting the 1. And this reads x cubed radical x. That's my answer. That's the simplified version of the square root of x to the 7th power. In case you're curious about where this whole dividing by 2 comes from, believe it or not, the radical sign is an exponent. The question is, well, what exponent is the radical sign? You might be totally confused when I say that, but if I say something is square rooted, I'm actually saying it's that number to the 1/2 power. So in other words, real world example here, if I have 3 to the 4th power, that's 3 times 3 times 3 times 3, which, by the way, happens to be 81. And yet I square root that. You know I should get 3 squared. But if you think about that, that is the same thing as saying 3 to the 4th divided by 2. And what's 4 over 2? Well, it's just 3 squared. And now some of you might think, okay, great, Mr. Elting. Well, when I take the square root of 7 and I divide by 2, won't I get 3.5 or 3.5. Well, believe it or not, 3.5 is exactly what we found before. Do you see it? X to the third times, not the square root of x, but that's actually x to the third times x to the 1/2 power. If you realize that this is 1/2, x to the 3.5 is x cubed times radical x. Pretty crazy stuff. You don't need to know all of that, but just know that when you do this, split it into x to the 6th times x, and then take the square root, and you will be just fine.